In this section, we study an important class of functions known as linear functions. A linear function is any function which can be written in the form f of x equals mx plus b. Now, this is a good example of this f of x notation. Notice that this really has three variables in it. It's got m, x, and b. But we know from this notation that the only true variable is x. X is our input variable. M and b are going to end up being constants. In fact, I'm guessing you've seen y equals mx plus b formula before. This is known as slope-intercept form. I'm guessing you've seen this before and used it in other algebra classes, where m is the slope and the point 0, comma b is the y-intercept. Alright, so y-intercept we've looked at before. We've looked at x and y-intercepts earlier in this course. What does slope mean? Slope is a ratio. It's the ratio of rise to run. And I'm guessing you've seen this formula before. M equals y2 minus y1 over x2 minus x1. Sometimes that's written as the change in y over the change in x. Alright, so slope really tells us two things about the line. Slope tells us how steep the line is. If the slope is a very big number, like 8, well, it's not a huge number, but a number like 8, the line is going to be very close to vertical, very straight up and down. If the slope is a pretty small number, like a half, the line is going to be quite flat, quite horizontal. The other thing that slope tells us is the direction. And what I mean by direction is, the line looks differently depending on if the slope is positive or negative. If the slope of the line is positive, the line will run one way, and if the slope of the line is negative, the line will run the other way. And let me draw you a couple of pictures and show you what I mean. Okay, so let's say I give you the function f of x equals 2x minus 3. Alright, well, the first thing I notice about this function is my intercept is negative 3. So I would, on my graph, I would draw the point 0, negative 3. And then my slope is 2. And I would think of 2 as being 2 over 1. So I get my rise and my run. So I start at my intercept 0, negative 3. The slope tells me go up 2 over 1. So there would be another point on the line. Go up 2 over 1. There would be a third point on the line. I move my graph a little bit. Let me see if I can move it back. Alright, so up 2 over 1. Okay, and then I would connect with a line. Okay, simple as that. That's how you use the slope and the intercept to graph. Now, let me give you one that has a negative slope. How about g of x equals negative 1/3 x plus 5. Alright, this time my intercept is 0, comma 5. So I put a dot right there. And this time my slope is negative 1/3. So, notice when my slope was positive 2, the line went up as I went from left to right. With my slope being negative, my line should go down. And this time I have a slope of 1/3, negative 1/3. So that should be pretty flat. So let's see. I go down 1 over 3. So that would be right there. And I could do it again. Down 1 over 3. Like so. And then I connect my dots. So you can see how that line is quite a bit flatter than the first line. And it runs in the opposite direction. It runs downhill as I go from left to right. Okay, so in your homework, you're going to have some questions where you graph like that. you're going to have some other type of questions. Let's see the other type of questions you're going to have here. You might have a question like this. Find the slope and intercept, y-intercept. And they might give you y equals 2/5 x plus 4. Well, for that one, there's really no work to do. The y-intercept is 0, 4. The slope is 2/5. Really nothing to do there. Let's try a slightly different one. How about y? That's not what I want. How about 2x plus 3y equals 9. Alright, well, I'll have a lot of students make a mistake on this one. A lot of students will say, well, the number in front of the x, that's the slope, so the slope is 2, and this number over here, the 9, that must be the intercept. It doesn't work that way. In order to be able to give me the slope and the intercept, you need to put the equation in slope-intercept form, which means you need to have the y all by itself. So we need to rewrite this equation. This would be 3y equals minus 2x plus 9. Subtract the 2x on both sides. And then, of course, we divide everything by 3. We end up with y equals negative 2/3 x plus 3. Alright, so now we have our y all by itself. Now I can tell you the intercept is 0, 3, and the slope is negative 2/3. So be careful of that. Don't let yourself fall into that easy trap. If you're going to tell me the slope and the intercept, make sure you have y all by itself. Alright, the next kind of thing I see in here, they'll say find the slope. And then they'll give you 2 points. So they might give you the point 2, 5, negative 3, 7. Well, not too bad. To find the slope, we have a formula. M equals y2 minus y1 over x2 minus x1. We just plug in our numbers and see. It really doesn't matter which one you call y1 and which one you call y2 as long as you're consistent. If you call the 7 to be y2, then the negative 3 has to be the x2. And that's the way I would normally do it. The negative 3, 7, that point came second, so I would call that one y2 and x2. So I would have 7 minus 5 divided by negative 3 minus 2. That's going to be 2 over negative 5, which we would normally write as negative 2/5. The minus sign is normally put on top, but that truly doesn't really matter. Now, just for fun, I'm going to switch them. So now, just for fun, let's say I called this one x1, y1, or x2, y2, and I called this one x1, y1. I just want to show you that it really doesn't matter. It doesn't matter which one is x1 and which one is x2 as long as you're consistent. So now I would have my slope is 5 minus 7 divided by 2 minus negative 3. So I would get negative 2 over 5. 2 minus negative 3 is 2 plus 3, that's 5. So I just wanted to do that just to show you that it doesn't really make a difference which one you call x2, which one you call x1, as long as you're consistent throughout the formula. Alright, I want to do just one more of those. How about if I give you the points 3, 9 and 3, negative 4. And again, I want you to find the slope. Slope would be, use our formula, y2 minus y1 over x2 minus x1. That would be negative 4 minus 9 over 3 minus 3. That's negative 13 over 0, undefined. You can never have 0 on bottom. It is possible for slope to be undefined. What that means is you have a special kind of line. Whenever your slope is undefined, you have a special kind of line. It's vertical. But notice that a vertical line is not a function. because a vertical line does not pass the vertical line test. Alright, the last kind of thing we see in this section are some word problems. In 2010, the traffic fatality rate in the United States was the lowest since the federal government began keeping records in 1966. There were 43,510 highway deaths in 2005. This number had decreased to 32,788 in 2010. Find the average rate of change in the number of highway deaths from 2005 to 2010. Alright, so first thing you need to know is average rate of change. Fancy way of saying slope. So they're asking you to find the slope here. Now, the question is, what's x and what's y? You need to read this carefully. Find the average rate of change in the number of highway deaths from 2005 to 2010. Notice that after the words average rate of change, number of highway deaths comes first. That's telling you what's going on top. So deaths is going on top. That means deaths is the y value, because remember our slope formula is m equals y2 minus y1 over x2 minus x1. Alright, so you got to read the problem carefully. Reading the problem carefully will tell you which is x, which is y. So what we really have here is we really have 2 points. We have the year 2005 with 43,510 deaths, and we have the year 2010 with 32,788 deaths. Alright, so what they've done in this word problem, they've given us 2 points. From the wording of the word problem, they told us which numbers should be x's and which ones should be y's. So now we're all set. We find our slope. 32788 minus 43510 divided by 2010 minus 2005. Grab my calculator here. I get negative 10,722 divided by 5, which is a perfectly correct answer. But I think in this problem I would actually divide by the 5 and see what I get. I get minus 2144.4. So what that tells me is that on average the number of deaths was dropping because it's negative, dropping by 2,144 per year. So that's kind of why in this case it would make sense to actually do that division by 5 and write it in that format.